With Hartford Steam Boiler Inspection and Insurance Company. And I've been with the company about 25 years now. And prior to that, I was in the U.S. Navy on board submarines, and I did that for about 10 years. I'm the Director of Engineering for the Texas Mountain States, which includes Utah and St. Louis, Missouri, all that. And I'm the Director of Engineering for that group. Most of my time at Hartford, I actually spent in the field doing boiler inspections. Now, the boiler inspections I used to do were not the heating boilers you see, but the big power boilers, the big utility boilers at the power plants. You know, these things are like several stories tall, 14 stories tall, something like that. And when we did an internal inspection of those, I mean, we were in there for a few days. I mean, we actually climbed inside these boilers and do the inspection. Now, one thing I noticed about doing these big power boilers, and because of the pressure of the high heat, but those manuals that you actually have to get into to climb into the boiler, after a couple of years, they start to shrink. I was like, wow, last year I was able to get into this thing real easy. Okay, so what do you call a boiler inspector who can't get into a boiler to do an inspection?
Boiler operator?
Director of Engineering. So that's how I got my position, okay? So not even sitting around the country while I'm safe. All right, today I want to talk about the boiler inspection process, loss prevention activities. It was real good to hear Jake up here talk about some of the electrical inspections, because one of our largest exposures where we see most of our losses is on the electrical limb, okay? And he's talking about infrared inspections and things like that. I mean, those are great tools to help minimize or prevent electrical losses. So let's go ahead and get started here. Let me get this to work. All right, first of all, we're going to talk about what is a boiler, okay? A boiler is going to be anything that's going to be used to generate heat, or heat up water, or generate steam, which is used for external to use. Steam that's strictly heated, that's mainly for the big utility, the big process, industrial systems. Okay, talk about the basic types of boiler categories, all right? First of all, you got your big power boilers. And these are going to be anything that have a pressure rating of over 15 psi, all right? And I don't think you guys have anything, any power boilers or anything like that. Now, some of the places you see the power boilers are, like I said, in the industrial application, but sometimes even a little small laundry, okay, the little steam process units they have back there are considered power boilers. The reason why we need to know the boiler categories is because that dictates the frequency of the inspections. Okay. High temperature hot water boilers, that's mainly used for the industrial application. You don't see too many of those anymore. And of course, what you're mainly going to see here is the heating boilers. All right. Two basic types of boilers. We're going to have a water tube boiler and a fire tube. Now the water tube boiler, just like it says, here inside the tubes of the boiler, we're going to have water. The water is going to rotate, it's going to circulate between the two drums. We call it the steam drum and the mud drum via the tubes. Once the water is heated inside these tubes, generally you're going to be producing steam inside the steam drum. Now, there are some big water tube boilers that are used for hot water heating applications, but they're kind of few and far between. Mainly you're going to see a water tube boiler, or a decent sized one like this, mainly going to be used in the large industrial application. Typically what you'll see, here's a Cleaver Brooks. Now, they are making some smaller water tube boilers for heating application, but once again, these are very large facilities. This is that big utility boiler that I was talking about earlier. You can kind of see how big these things are. And of course, we don't have anything like this here. But just to give you some reference, that's me right there with the boiler inspector down there. Okay? So you can see how tall these stories are. And the one thing I generally get upset about when I do an inspection of this is when the elevator's not working. Yeah, but typically, like I said, once again, there's a basic steam drum and mud drum, there's a circulating tube, and all these right here are basically tubes here, okay? Now these things here, these are fired with coal these days, pulverized coal. But just like I said, just to give you some scale as to what's really out there. But mainly what you guys are going to be dealing with are fire tube boilers. It's just the opposite of the water tube boilers. In this case, you're actually going to have the combustion, products of combustion going inside the tubes. And the water, which is going to be heated for hot water or for steam, is going to be surrounding the boilers. So it's good to determine what type of boiler you have, fire tube or water tube. Now here's your basic, what we call fire tube Scotch Marine boiler. There's your furnace right there, which is blowing out your products of combustion. It goes through what we call the main furnace tube, and then it bounces off the back walls and goes through the tubes themselves. So you got the hot gas is passing through the tubes, and the water is surrounding the tubes inside the shell. And then from that point, we're going to use that to produce either heat, hot water, steam, or whatever. Now this is more in common than what you guys probably would see right here. This is your smaller fire tube Scotch Marine boiler. And this is typically what we see in commercial and municipal type locations. This boiler here may be rated about what we call 100 horsepower. Typically, we're going to rate these fire tube boilers what we call horsepower. And just for conversion factor, like 1 horsepower is equal to 34.5 pounds per hour of steam. Okay, what could possibly go wrong with your boiler? A lot, okay? First of all, let's take a look at some typical boiler failures, okay? First of all, the major types of major causes of our boiler failures is going to be what we call low water condition. The next cause would be poor maintenance, which can lead to a low water condition. And then the other most common type of cause of failure would be called failure of the control and safety devices. Now, what are some of the control and safety devices you have in the boiler? What do you think?
Flow switch.
Flow switch, okay. What's your last line of defense to keep that thing from blowing up or over pressure?
Control.
All pressure valve.
Yeah, pressure relief valve, safety valve, and everything like that, okay? I mean, that safety valve, that's your last line of defense. Because we're going to see what can happen if you don't regularly check that safety valve, okay? All right, low water condition. Basically what happens when you get a low water condition, the boiler is going along, fine, backed up and happy, but it calls for water and it doesn't get it. One, it doesn't call for water. It, of course, never receives it. And once the water is allowed to boil dry, you can get catastrophic failure of the boiler. So one is going to give you over temperature, it's going to overheat your boiler. And this can result in either cause extensive damage to the boiler, melting of some of the tubes, or it can give you a catastrophic failure of the boiler. Now here's an example of what we call extensive damage. Remember that main furnace tube where the fire is going through? This is it right here. They're not supposed to look like that, right? This happens when you basically boil the water dry, and that main furnace basically just starts to melt and separate from what we call the tube sheet here. All these little holes here are basically tubes, and you can kind of see the tubes there in the background, okay? In this case right here, you're going to have to replace the main furnace. You most likely may have to replace the tube sheet. You're talking a significant amount of damage here. And this will happen if you're lucky. If you're not lucky, this is what can happen, okay? The boiler can actually leave the boiler room, right? When we do our inspections, we prefer that to do the inspections inside the boiler room, okay? That's the best place for it. Now this is an example of what we call catastrophic failure. like I said, you get a low water condition, these things are building up a lot of pressure, a lot of steam, okay? And once that water, goes to atmospheric pressure, I think the way it expands is something like 16,000, spaces to 1, all right? So this thing can take off like a jet engine, okay? It can cause some serious damage along the way. So there can be some significant issues here. All right, poor maintenance, all right? Okay, this is a typical plug in what we call a older type water tube boiler. And you can start to see it start to leak, all right? One thing about these leaks, okay, they don't stop, all right? Putting in some stop leak is not going to do it either, okay? You got a leak, you got to correct it, all right? Go ahead and correct it, it's just going to get worse. And if you start getting a leak, the leaks will start getting worse, you're going to start introducing more makeup water to the boiler, more oxygen is coming into the boiler, more scale and more deterioration of the boiler is going to occur. So if you got a leak, take care of it right away. Here's an example of more of this. This right here, this is kind of a poor design. This right here is actually the discharge pipe of a low water cutout device. The low water cutout device is basically designed to turn the boiler off if there's a low water condition. And we recommend every so often flushing that low water cutout device to prevent mud from building up in there. And they are doing that. So look at the discharge is coming right off on. This is your gas line, it's like a road up. This is like a power transformer right here, a control transformer. That's like wires here. Yeah, they're all blowing you down, and we applaud them for that, okay? But let's see where we're blowing you down to. Okay? When you put the boiler back, make sure that people who are disassembling and assembling the boiler know what they're doing, okay? If you see anything wrong with this picture, now this is what we call a handhold, all right? Basically, you take the handhold off so you can get inside the boiler to either clean it or put in some type of inhibitors or whatever. But once a year, when we do an internal inspection, we basically look through these, what we call these handholds, and these have to be taken off. And once you take off this handhold, there's a rubber gasket or some type of gasket that goes around it. But there's something wrong with this particular one when they put it back together. Huh? Kind of leaking. Kind of backwards. See this right here?
That's supposed to be on the inside.
It should be like that, okay? Right now, are you getting much of a bite along this connection bar right here? That's why this is supposed to go up and down. You have more of a tighter connection on this. This thing is eventually going to leak on you. And you can even see where it's supposed to be, okay? Where, the bar is supposed to be on this one. Okay, this is the inside of one of those volume tube boilers, okay? Now, typically when we come in to do the inspection, we like to come in right after you take the boiler offline so that we can take a look and see what it looks like. Now, some inspectors like to take a look at it after you get it cleaned up. If that's the case, I always recommend saving some of the scale, just so you can kind of see what kind of scale is building up. Earlier, Jay talked about water chemistry, proper makeup water, proper water chemistry. Having a good certified water tech come in there. You can always tell the sign of a really good water company is, do they come in when you disassemble your boiler for your inspection? Do they come in and take a look at the water size of the water? Because if you're buying a lot of water chemicals and you're getting a lot of scale like this, they just selling you chemicals and not doing a good job here. So in the good scheme of good and bad, okay, this is bad. Right? So what's wrong with having the scale on there? What's bad about having a lot of scale in the boiler?
No transfer.
Huh?
No heat transfer.
Yeah, it lowers the heat transfer, and what does that result in?
Higher utility costs.
High utility costs, okay? And eventually you're going to start to deteriorate that metal underneath there, all right? And eventually you're going to start to get some corrosion inside that metal, and eventually it's going to start to leak. Now, one thing about having the insurance, like I said, along besides doing the boiler inspections, we also insure all the boilers. Okay, so if something happens to them and they blow up, or they take a walk like that other boiler we saw, That's covered from our insurance, okay? Now, the one thing that's not covered, and generally not covered by any insurance, is corrosion, okay? If you got a boiler that's failed because of corrosion, you know, just finally wasted away, the metal's wasted away because of poor water conditions, so a lot of times that won't be covered by the insurance, right? So another reason to keep the scale down to a minimum. Which brings us to our next thing, optimization. All right? A quarter-inch of scale, 1/4 inch of scale, can actually cost you, increase your fuel cost, your fuel usage, by 70%, just from a 1/4 inch of scale. So one of the things our inspectors are going to start doing, as we come around to do our boiler inspections, we're going to start making what we call optimization recommendations. If we see a way that you can operate that equipment more efficiently, be it electrical, boilers, HVAC, or whatever, we're going to say, you know, go ahead and clean off the scale. If you remove this much scale, you'll see your fuel cost that you decrease by so much. Same thing about any type of air leaks or any type of soot buildup on the boilers. And we'll actually direct you to what we call our equipment efficiency calculators. We make a recommendation as far as to operate that boiler in the most optimum condition. We'll send you to this calculators. Like I said, we have calculators in 4 different sections: boilers, electrical, HVAC, and mechanical. And if you want to get some experience, just some idea of how much it would cost you, or how much you would save, you can go to one of our calculators and you put in the information on the type of boiler you have, as far as, fire tube, water tube, how it's being fired, on gas, on oil, whatever, design pressure, design temperature. If you put all that information in, you can actually start to see how much you might start to save just by knocking off the scale. In this particular instance, we had just 1/16 of an inch of scale, okay? And our estimated savings can be anywhere from $1,000 to $3,500 per year, just on this one boiler, on fuel savings. And that's just from 1/16 of an inch of scale being knocked off the boiler. And a lot of times, you see a lot more scale built up on that. So we'll start making some of these optimization recommendations. All right, another type of failure controls and safety devices. Okay, some of our control and safety devices would be safety relief valves, safety valves, low water cutouts. What else?
High temp.
High temperature limit switches, pressure switches if you have any type of steam boiler or anything like that. Here's a safety valve. What's wrong with this safety valve? Yeah. Remember all that scale that we saw on the tubes? That scale can also start to build up on the inside of the safety valve. Do we have proper over safety protection on this boiler now? And that's the one thing. If our inspectors come in and we do an inspection and we have some reason to believe that that safety valve is no longer operable, we're going to have to recommend that you take that boiler offline, okay, and replace the safety valve before you can bring it back up again. Because that is a serious safety concern. What kind of things can you do to try to help prevent that, to help minimize that? Yeah, go ahead and pop that safety valve every so often. How many guys actually pop a safety valve in your facilities? Take the safety valve and lift it. Okay? We hear a lot of people say they don't like to lift them up, they don't like to test them because they never reseat. They never, they start to leak after you pop them once or twice. Well, the reason it does that is because you never tested it to begin with. All that scale and crud starts to build up on the seat of the valve and the disc, and so you don't have that good seating connection anymore. So of course it's going to leak, all right? Well, hell, if it leaked, it might not even work to begin with. Right? How many guys have hot water heaters at home? You test those safety valves? Pop those when the last time you popped those puppies? You see this weekend? recommend doing that. I recommend doing it like every 6 months, okay? I mean, that thing goes just as, I mean, we'll see a video on that, okay? What's wrong with the safety valve? Well, what happened, we came in to do, we popped it, okay? And it was leaking, we did the test on it, and it was leaking, and they told the, mechanic to go down there and keep it from leaking. Well, they stopped it from leaking, all right, okay? Anybody recognize what kind of vessel this is right here? Yeah, hot water tank, okay, hot water heater, okay? Now, unfortunately, we had this situation happen down in Oklahoma City back in '82. It wasn't just like this. I mean, this thing actually had a discharge line on it, and it was leaking. And the guy did the same thing. He went ahead and tried to keep it from leaking, and screwed a cap on it. Okay. Unfortunately, something happened to the temperature switch, and this thing just kept building up pressure, and the safety valve tried to relieve itself. Now, this was out of school, and this was in the cafeteria, and the whole tank finally let go right about lunchtime. And unfortunately, about 6 kids died from this. So, that's why, if we ever see any reason why a safety valve that we believe is not in operation or is not going to function properly, we will require you to take it offline and go ahead and shut it down. These things are dangerous. I recommend, if you got a discharge line, which you should have a discharge line on the safety valves, to point it off to a safe point of discharge. At the bottom of the line, go ahead and, cut it out at an angle. That'll prevent some enterprising young, guy from putting a cap on it or something. Remember I told you about that low water cutout and how you're supposed to drain that ever so often? This is one reason why we like to drain those low water cutouts. A lot of times it's just an empty chamber with a floating ball in there. And this is what you can see that's can build up in there, a lot of sludge and a lot of mud. If this low water cutout device don't work, okay, that's why we recommend while the thing is running, while it's online, you go ahead and flush it out, okay? Flush it out until you get some clean water out of it. Flush it out and actually test the shutdown feature of it. This is the electrical side of the low water cutout device. And what do you think? How do you think this one looks?
A little crude.
We want to make sure we got the right type of wires for the high temperature application, okay? And you don't see this too much. A lot of them now are micro switches, but these are some of the old mercury switches, okay? If you have any of them that are like that with the old mercury switches, make sure the mercury's in good condition. Make sure it's a nice, solid, blob of mercury in there. It's not cloudy. It's not speckled all throughout the bulb. Like I said, this is an older type, but there's still a lot of them out there like this. These are pressure temperature switches. Covers missing. You see anything like that, you definitely might want to go ahead and test that or replace it. You've got wires that are coming out of the connection box there. All right. I like this one. This is this pressure switch. Okay. Can you see anything wrong with this pressure switch? Huh?
Negative pressure?
Well,
Something's holding the mercury safety switch. Yeah.
Yeah, piece of cardboard in there, okay? They were actually doing some type of maintenance and they were actually doing some type of test on this boiler. And they wanted to make sure it didn't trip off with overpressure or whatever. So to prevent that, they actually put in something to keep from tripping out, okay? Anytime you bypass controls is never a good idea. Because if they're left in there, you find it on the inspection. That inspection might go a little difficult that day. All right, you're going to boiler drivers, okay? We'll make sure about the proper operation, proper maintenance, and routine inspections. If you operate these boilers in accordance with the standard procedures, if you are doing the type of maintenance that is required, and we do have routine inspections, we can help prevent a lot of boiler breakers. And in this case, this is an example of it was being operated improperly. Obviously, the maintenance wasn't being done correctly, or it was done incorrectly. And obviously, the routine inspection, I want to have a disclaimer, we did not inspect this boiler, okay? It wasn't HSB. Obviously, the inspection didn't catch the things that were going wrong. Now, typically, if you have a boiler failure, it's usually going to take a series of events to happen. It's usually not going to be just one device go bad that's going to cause your boiler failure, okay? It's going to be a series of events. And that's what happened at this location. This is a 5-2 boiler. That's not the boiler room, okay? That's actually the manufacturing boiler. And the boiler room is right adjacent to it. The boiler's not supposed to be in there. And this is what the boiler looks like. So what do you think happened on this boiler? Low water. Got that classic melting of the main furnace, okay? Unfortunately, you just didn't get a, failure of the boiler. You just didn't get extensive damage. You got catastrophic failure. And that sheet actually let loose, and all the water, whatever water was left in there, expanded to steam. This thing took off like a rocket, and it went into the adjacent room. Took down a lot of pieces of equipment, and it's America no one was killed in this thing. Okay, there's a boiler back there. This is the boiler room. This is where it's supposed to be, okay? In fact, this is the exhaust stack. So this is where the boiler started, and that's where it ended up at. You see, that's a pretty decent sized ball to knock the hole through, okay? That's the outside wall of the boiler room. And this is looking at the outside of the boiler room from the east side. Yeah, from the outside side. So you can see, it actually took the outside wall down also. Basically what happened when the boiler let go, that back door, the back furnace door, went one way and took out that wall, and the boiler went the opposite way and took out the opposite wall. There's a sister boiler right there. And take a look at that back door on this one. This is not the one that failed, okay? But there's the back door, the one that failed. There's the boiler room, and there's the back door there. So you can see this thing kind of took off and landed several hundred feet away. And like I said, it's a miracle no one died in this thing. See how thick these walls are right here. Earlier we talked about proper operation, proper maintenance, proper inspections. Well, here they weren't operating the boiler properly. Because these things, these boilers operate automatically, okay? As the water level goes down, it's supposed to automatically call for more water. Typically on these size boilers, you're going to have about 2 low water cutoff rights. One, to turn the pumps on to bring water into the boiler, and the second as a backup to actually turn the fire off when water is too low. Now, for some reason, they were having problems with the automatic feed level coming into the boiler. And this is the automatic feed valve right here. As the water level gets low, this valve is supposed to open up so often by this mechanical linkage with this motor right here. But one thing that when we looked real close at that automatic feed valve, we saw this. It wasn't connected. The linkage wasn't connected at all. In fact, the way they were feeding the water was on the bypass. Okay? So they weren't feeding it through the automatic feed valve. So that was one thing, proper operation. They weren't operating the water properly. You can kind of see how they started to open the valve where the water finally went in there. If you do have a boiler that's experiencing low water condition, what do you want to do? What's the last thing you want to do? The first thing you want to do is shut the boiler down, right? The last thing you wanna do is
Put cold water in
put cold water in there, and that's what they did here. They actually had the security video online, and if you Google it, you can actually go and you can actually see the guy. He's in, there's no sound on it, but he's inside the boiler room, walking around, doing this, doing his duties as usual. And then you see him walk out of the frame of the camera, and all of a sudden you see all this steam that's come through the boiler room. Papers flying, steam everywhere, and you see the boiler operator just running past the camera. So they had everything right there on video, so we kind of figured out what happened. We weren't operating the boiler correctly. The boiler dry fired, the alarm went off, it didn't cut off the boiler for some reason, it didn't kill it. So he tried to add water to it, and this is what happened. Remember I said we have two low water cutouts? One to turn water on, bring water in, and the second one to actually kill the boiler. Well, you would have thought that the second cutout would have actually turned the water off, right? Well, we kind of thought the same thing. But first of all, we wanted to find out why the thing wasn't calling for water. Well, this is the low water cutout device here. And what do we notice about some of the contacts there? They're broken off, okay? So proper operation says that at least once a month you should test the low water cutout feature. And another part of preventing boiler inspection is routine inspections, okay? The inspector should have, during the internal inspection, should have caught this. There's the load chamber itself. Actually, the arm is kind of bent if you take a real close look at it. And there's the backup low water cutout relay. These are the backup relays. This is what's supposed to turn the boiler off. Now, this is the type of relay they're supposed to have. Okay? And this is the type of relay that they actually have. These relays are supposed to have what they call a manual reset. Basically, if it shuts off on low water, before you can start the boiler up, you have to go ahead and reset that low water cutout device. Now take a look at these contacts here. If you take a look at these set of contacts, these are what we call normally open contacts. Now these two relays look alike, right? But take a look at the diagrams on these cutout devices. These two contacts are what we call normally open, but this contact right here is not. This is a normally closed contact. So doing repairs or doing some type of maintenance on the boiler, they had to replace the relay. They put in the wrong type. Kind of look alike, right? But they put in the wrong type.
One has a button, the other doesn't have a button.
Right, it doesn't have the manual reset. So like I said, it took a series of events which caused that accident, okay? One, they weren't operating properly. Two, they had some improper maintenance going on. And three, the routine inspections didn't catch the fact that these low water cutout devices were bad, wrong types, and they weren't operating the boiler properly. So a lot of things have to come together for this to happen. All right, we're going to take a look here at the video. Let's see if I can get the hotspot going here. Like I said, we all have boilers at home, right? Hot water heaters. How often do you check your low water cutout device? Your safety valve on the hot water heater. Okay? We recommend popping out at least every 6 months, at the very least once a year, but every 6 months. When the last time you cleaned out the boiler? Cleaned out your hot water heater? open it up, drain it, and clean all that hard deposit salts out of it.
It's pretty hard.
It's pretty hard, especially if you're not doing it for a while.
Yeah.
And let's see, do we have any sound here? Oh.
Crutches, couldn't move my leg. So going from winning medals at a
In water heater time, the boys were blown away by the a 30-gallon water experiment. But what we didn't show you was what happened when we ramped up to a 52-gallon tank.
Small, no room. Medium, boom. Extra large, confident.
It's the same type, it's set up the same way with all the safeties removed. Everything's the same except it's larger. So I would expect that this is gonna blow up exactly the same way, but it's gonna be a little bit more energetic.
To measure just how energetic, Jamie lays out shock watch stickers around the tank.
When these water heaters explode, they make a big bang just like an explosive. Now that produces a shock wave. We want to see exactly what that shock wave is. Is it actually comparable to a couple sticks of dynamite?
At least this time, the guys know where to look. Straight up.
You want to spot how high it goes in the air?
Okay.
You can.
That's pretty high.
Yeah.
Once again, they count up the mounting pressure.
We're at about 265 psi and climbing rapidly. So be on your guard. Anything could happen from here on in. We're now at 300 psi, double what the tank's rated for. Be on your guard. Okay, everybody in here.
Lucky we were all on our guard. The heater pushed off the ground with a mighty amount of thrust.
Look at how high.
Down it comes. Now.
Wow.
The other guy in the bottom over there.
Wow, that was just around 315 and that acted just like a rocket.
Yeah, I'm saying that went up maybe 500 feet.
The boom was louder. Whoa! And this time, knowing that it was flying up in the air, both Jamie and I took pains to watch it. And watch it. And it hung for like, I didn't 12, 13 seconds at least. It was stunning.
The telltale signs of a rocket are strewn all over the runway.
Wow, look at that.
That was my cave.
Yeah, the full bowl before we started this test.
It went from like this to like that.
Whoop.
Jamie checks out his shock stickers.
These things register shock. They're all tripped. The green one represents 100 G. That's supposed to be lethal. So,
Note to self, never use a water heater as a drink stand.
There's another video out there, same group doing the same thing, except this time they do it with a mock-up of a house. Okay? And you can actually see how it actually, when it goes through the roof, it actually takes the roof off the foundation as it goes through the building. Okay? They're showing the water, the hot water heater inside the basement, and it's coming up through several floors, and before it actually goes through the roof. And the one thing I like about that video, they've got a mannequin sitting on the couch in front of the TV in the living room, okay? And it goes up right in front of him, okay? So I mean, it takes him with it and everything, all right? Like, okay, that would be me right there on Sunday watching you talk. So like, I said, at least once a year, 6 months preferably, you know, test that safety valve, okay? Go ahead and test it and make sure it's working. Because really, these things, the only automatic control you have on there is, you know, the temperature switch and the automatic firing device on that. If that fails and the pressure continues to rise up on the water heater, if that safety valve isn't properly working or if it's no longer any good, that's what's going to happen. It's going to go right through your house. Okay? All right. As far as boiler operation, you know, making sure you prepare the boiler for operation, starting up the boiler, make sure you observe the heat up rate, make sure you don't heat this thing up too fast, follow the standard operating procedures that come with boilers. Regular operations, make sure the low water cutoff devices are working, like we saw in the other boiler when it wasn't. Control the safety devices, test those to make sure they're all working. How many guys actually use boiler logs? We recommend using the boiler logs because on the logs, they actually have places for you to annotate where you tested the low water cutoff feature, where you tested the safety valve, okay? There's places to tell you how often you should do it. When we come in to do a boiler inspection, if we see there's a set of boiler logs in there, well, we know these people are actually taking care and following proper procedures on the boilers. Where can you get some boiler logs? You can make them up, or since you guys are insured by HSB, you can go to our website, okay? Our website is www.hsb.com, okay? And I'm gonna leave a bunch of my cards up here also, which has the website on there also. But www.hsb.com. You can go on there to our website, and under the tab called Information Resources, you can actually download a set of logs. You can download a set of logs for high pressure boilers, heating boilers, even air conditioning boilers. So you can download them, it comes off in a PDF form, you can cut them out and make as many copies as you need. Boiler codes, okay. All boilers are supposed to be built to the ASME code, right? Our boilers are built to Section 1, your heating boilers are built to Section 4, and then your pressure vessels, and I believe Utah does require your unfired pressure vessels to be inspected. They're built to Section 8. So all your pressurized vessels should be built to the ASME code. How do you know if it's built to the ASME code? Huh? Take a look at the nameplate, okay, the label, all right? First of all, there's two giveaways. It's going to have the ASME symbol, the stamp, okay? For heating boilers, it's going to be an H. And I think that's all you guys really use is heating boilers. Heating boilers is going to have an H stamp on it. And for the unfired pressure vessel, it'll have a U stamp on it. That indicates that it is built to ASME standards. Another way to determine if it's built to the ASME standards, if it has what they call a national board number. A national board number. Now there is one type of boiler which we haven't talked about. They're called cast iron boilers, right? You don't see too many of them. They're mainly used a lot out east, but I believe you guys still have some in your facilities. Does anybody have any cast iron boilers?
We have a direct fire boiler that all it has is just a standard heat exchanger. It doesn't have the fire tube.